Hello, I am Arish Chavan, and today I'm presenting my MN-125 project, a space weather analysis system built in MATLAB that monitors geomagnetic activity and predicts aurora visibility. Space weather refers to changing conditions in space caused by our sun's activity. Just like Earth's weather affects our daily lives, space weather can impact our technology and create beautiful natural phenomena. Why does this matter? This isn't just academic. In November 2025, we experienced G4 level storms that caused auroras to be visible in the middle of the United States and caused disrupted satellite operations. Understanding space weather is critical for our technology-dependent society. Solar Cycle 2025 current status. We're currently at solar maximum, the most active phase of solar cycle 25. This means more frequent geometric storms and increased aurora activity. My system tracks this in real time. My system accomplishments. I built a comprehensive system that integrates multiple data sources to provide a complete picture of current space weather conditions and predict aurora visibility for any location on Earth. My system automatically retrieves data from three sources. It gives real-time geomagnetic activity analysis. It has solar cycle tracking and solar wind parameter monitoring and aurora visibility prediction. The system integrates three authoritative data sources: the KP index from Germany, solar cycle data from NOAA, and real-time solar wind measurements from NASA's ACE satellite. The KP index explained. The KP index is the key metric for geomagnetic activity. Values above 5 indicate storm conditions, which is when auroras become visible at lower altitudes. If the KP is from 0 to 2, then it is quiet. If it's from 3 to 4, then it's unsettled. From 5 to 6, it's a storm G1 to G2. If it's 7 to 8, it is a G3 to G4 storm. If it's a KP9, then it's a severe storm at G5. The KP index updates every 3 hours. System architecture. The system uses a modular architecture with 6 analysis options. Each of the options are graphs. Each module handles specific aspects of the space weather monitoring system. Here is a demo of how the program works. This is the KP index series for the last 30 days, and there's the KP index distribution. This is the solar cycle 25 progression, and this is the smooth version. This is NASA's ACE satellite solar wind readings. This is the geomagnetic storm frequency. And these are two other important graphs. My program also gives a statistical summary of the mean KP and the standard deviation of it. It also, this year, the max KP has hit 6.84. It's mostly been quiet, but with 72.5%. It's unsettled 24.2%, and it's been a storm for 3.3%, and it has not been severe. In the solar cycle 25, the current sunspot number is 155.4. The most observed is 177, and the projected peak, it will be MN-150, and the cycle progress so far has been 59%. The solar wind statistics, the density has been 3.44 plus minus 2.56 for air, and the speed has been 444.7 plus minus 125.4 kilometers per second. The temperature has been 1.2 to the 5th degrees Kelvin, and the dynamic pressure has been 1.43 plus or minus 2.2. The geomagnetic storms in the past 5 years, the total amount of storms has been 349. There's been 249 minor storms, accounting for 69.1%. There's been 84 moderate storms, accounting for 24.1%. There's been 24 strong storms, accounting for 6.9%. And the average of storms per month is 5.82 in the last 5 years. It also gives a mean KP per day, which means at 12 a.m. it gave a mean KP of 1.26, and around 12 p.m. it gave around 1.91 kp. And that is the complete analysis of my program. Real-world applications. For the general public, it helps with aurora viewing forecasts, space weather awareness. It works as an educational tool. For infrastructure operators, it helps with power grid planning, communication system backup, and risk assessment, because you don't want your power going out at a random time due to solar activity. For scientists, it helps with research validation, model testing, and long-term trends. In November 2025, there was a storm event. It was a G4 storm. It lasted from November 9th to November 10th. The max KP on that day was 6.1. The max solar speed on that day was 720 kps. And the system detected high speed stream and predicted aurora visibility, and it gave a accurate KP forecasting. Challenges and solutions. Every project has challenges. I addressed data availability by implementing automatic fallback to simulated data, and it handled missing readings with proper NAND management, and I created custom parameters for different file formats, and it created a more robust and reliable system. Some problems we had were data availabilities. For example, some of the NOAA data was missing in some parts of it, so I had to have some of that part simulated by my program, and others had some input errors, and those just had to be cleared up by some simulated data. Thank you for watching my presentation, and I hope you enjoyed it.